Welcome to Brain Vision.
Okay, we have got this trisubstituted cyclohexane. And we've got to draw this using an overhead planar view using wedges and dashes. Well, I think what could be helpful here then is to see whether each of these groups is the higher or the lower of the two groups that will be on a given carbon. What do I mean by that? If I look at this carbon that has a chlorine, I know that that carbon also has a hydrogen. Is that hydrogen above or below the chlorine? Right, so then it can help to sort of know what the shape of chairs in general is. Right, so if I draw a chair, and then I start drawing on the positions, I know that these ones that point like up, like that, have axial groups that go up and equatorial groups that go down. And every other position shares that, right? Point being that if chlorine is axial up, then I know that that hydrogen that's not drawn is below it. And if this fluorine is equatorial, then I know the hydrogen is axial and above it. And if this bromine, well, I haven't done that yet, but so on the other carbons, right, I know that down is axial, straight down under the page. And the equatorial groups are above it. Okay, so if this bromine is pointing straight down, I know that the hydrogen is above it, equatorial here. Okay, so once I've got this drawing, it's not so bad. I'm going to draw cyclohexane. I could designate any of these as carbon 1. I'm just going to start here and start numbering 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Okay. And then I know at carbon 1, we've got a wedge to chlorine. It's coming towards us if we're above the ring. At carbon 3, we've got a fluorine that's below the ring, right? Because it's below its hydrogen. The hydrogen is pointing towards us, and the fluorine is relative to that hydrogen pointing away. And then we get to carbon 4, and we look at this bromine, which, again, is below the ring relative to the hydrogen. So we're going to have a dash to bromine. And that's our overhead view.